Hello everyone and welcome back to my YouTube channel. In today's video we will tackle a highly instructive trigonometry problem that is perfect for pre-calculus and trigonometry students. We'll cover key concepts like understanding the relationships between sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. Determine where trigonometric functions are positive and negative with the all students take calculus trick, and use half-angle formulas to find exact values for the solutions of this problem. A viewer of mine sent this problem over to me, so if you have a problem or topic you'd like to see covered, comment below and I will happily make a video on it. So let's jump in and get started. The problem reads, if secant of alpha equals negative 17 over 8, and angle alpha is between pi and 3 pi over 2, then find the exact value of each of the following: A, sine alpha over 2, B, cosine alpha over 2, and C, tangent alpha over 2. So there's a lot to unpack here, but we should first look at each reciprocal trigonometric function. So sine of x, cosine of x, and tangent of x all have a reciprocal trigonometric function, respectively known as cosecant of x, secant of x, and cotangent of x. So let's write what they're equal to. So the cosecant of x is equal to 1 over the sine of x. So this is just the reciprocal of sine of x. And the secant of x is equal to 1 over the cosine of x. Again, the reciprocal of cosine of x. And finally, the cotangent of x is equal to 1 over the tangent of x. And again, the reciprocal of tangent of x. So this may seem pretty basic, but it's important that we're familiar with these concepts before we move on with this problem. And mainly we're going to focus on the secant of x equals 1 over the cosine of x because we're given secant of alpha in our problem. So that's what we're going to focus on mainly in this problem. So now that we have established these relationships, we can move on to the next part of this problem, analyzing the angle alpha. To analyze angle alpha, we need to study where trigonometric functions are positive and negative. This will come in handy later. To do this, I will show you a trick called All Students Take Calculus. I sketched this graph off camera and labeled each respective quadrant and the significant angles. So now let's use the All Students Take Calculus trick. Write each word in each quadrant moving in the order 1 through 4. So let's put all in quadrant 1. Let's put students in quadrant 2. Let's put take in quadrant 3. And let's put calculus in quadrant 4. Okay, great. Now, you may be asking me, George, why did you have me label my graph this way? You're about to see why. So the first letter of each word represents the trigonometric function that is positive in that quadrant. And knowing this will also give you the negative trigonometric functions in that quadrant. So in quadrant 1, the first letter of all is A, representing that all trigonometric functions, sine, cosine, and tangent, are positive in quadrant 1. So let's write that down. So the sine of x is positive. The cosine of x is positive. And the tangent of x is positive. Okay, cool. And you can also figure out the sign of their reciprocal counterparts this way. So because cosecant of x, secant of x, and cotangent of x are just the reciprocals of sine of x, cosine of x, and tangent of x, they carry over the same sign, basically. So positive 1 divided by a positive will give you a positive. So for all of these, their reciprocals will be positive as well. So let's write that down. So the cosecant of x is also positive. The secant of x is also positive. Oops. And the cotangent of x is also positive. So in quadrant 1, all trigonometric functions, including their reciprocals, are positive. Next, in quadrant 2, we have the word students with the first letter S, which stands for sine. This means that only the sine function is positive in quadrant 2. This also means that the cosine function is negative, and since the tangent is equal to the sine divided by cosine, we have a positive divided by a negative, meaning tangent is also negative. So let's write that down. So we have sine of x is positive, right? But we have that the cosine of x is negative. And the same is true for the tangent of x. And when we take the reciprocal trigonometric functions, we'll see that they'll have similar signage. So the cosecant of x will be positive in quadrant 2, positive divided by a positive. The secant of x will be negative, positive divided by a negative, that's a negative. And the cotangent of x will be negative, right? Positive divided by a negative, that's a negative. So now we have all of our information for quadrant 2. Next, let's look at quadrant 3, where we have the word take with the first letter t, which stands for tangent. This means that only the tangent function is positive in this quadrant, and for this to be true, both sine and cosine must be negative, because a negative divided by a negative is a positive. So let's write that down. So we have the sine of x is negative. The cosine of x is negative, but the tangent of x is positive. And let's do the reciprocals. So the cosecant of x will be negative as well. Positive divided by a negative is a negative. And then the secant of x will also be negative for the same reason. And the cotangent of x will be positive, right? Positive divided by a positive, that's a positive. So now we have all our information for quadrant 3. Finally, let's look at quadrant 4, which has the word calculus with the first letter C, which stands for cosine, meaning cosine is the only positive function in quadrant 4. Therefore, sine and tangent are negative. So let's write that down. So sine of x, that's going to be negative. But the cosine of x, that's going to be positive. And the tangent of x, that will be negative. And so now let's take reciprocals. So the cosecant of x will be negative. The secant of x will be positive. And the cotangent of x will be negative. All right, so we've thoroughly analyzed all trigonometric functions and their reciprocals using the all students take calculus method. We looked at every single quadrant, every single trigonometric function, and so now we know what the signage will look like for all of them, depending on the angle and the quadrant. Now that we've done that, let's look more closely at angle alpha. So from the problem, we're told that angle alpha is between pi and 3 pi over 2. But we're looking for what's called the half angle, which is alpha over 2. So alpha is between pi and 3 pi over 2. So that would be like this, right? That would put us in quadrant 3. But the half angle is not going to be in quadrant 3. The half angle is going to be somewhere else. So to find out where the half angle lies, we need to do something to this inequality. So first, let's divide everything by 2 so that we can get that middle term as alpha over 2. So what's that going to be? We're going to get pi over 2. Right? Pi divided by 2 is pi over 2. The middle term by design is alpha over 2. That's our half angle. And 3 pi over 2 divided by 2 is 3 pi over 4. So now we know where our half angle lies. And if we look at our graph here, it's between pi over 2 and 3 pi over 4, which is not quite pi. 3 pi over 4 is halfway from pi over 2 to pi. So we know our half angle, I'm just going to, for 1 second, draw right over this, is going to be in quadrant 2, right? From pi over 2 to 3 pi over 4. So when we analyze the signage of our answers, we're going to look at the signage from quadrant 2, not quadrant 3. And this is a super common mistake, so be really careful when you're addressing those half angle problems, because the quadrant's going to change depending on what your answer looks like. So be careful of that. So now that we've nailed down where the half angle lies and know how to determine signs using the all students take calculus trick, we're ready to tackle the rest of the problem confidently. So our next step will be to find cosine of alpha. And we know from the problem that secant of alpha is equal to negative 17 over 8. That just came from the problem. And we also know that secant is the reciprocal trigonometric function of cosine. So we can say that secant of alpha is also equal to 1 over the cosine of alpha. And so now we can just substitute negative 17 over 8 for secant alpha. So let's do that. Negative 17 over 8 equals 1 over the cosine of alpha. And now to solve for the cosine of alpha, we can just flip the equation. So we can basically just say that negative 8 over 17 is equal to the cosine of alpha. And if we rewrite that where cosine alpha is first, we get that the cosine of alpha is equal to negative 8 over 17. So let's put a green box around that. I'm going to need that for later. Cool. Let's move on to the next step. So the final step of this problem is to find the exact value of sine alpha over 2, cosine alpha over 2, and tangent alpha over 2. And we can do this using the trigonometric identities known as half-angle formulas. Now, I won't prove them in this video as the proofs are complicated and time-consuming, but you can use these identities to calculate the half angle, in this case, alpha over 2. So the first formula is sine. I'm just going to write alpha over 2 because that's what we're using for this problem, but theta over 2, really anything that represents the angle would work for this. So sine alpha over 2 is going to be equal to plus or minus the square root of 1 minus the cosine of alpha over 2. Okay, so that's the first one. That's for the sine. The second one is for the cosine. So that's the cosine of alpha over 2. And this is equal to, again, plus or minus the square root of 1 plus cosine alpha over 2. And finally, we have the formula for the tangent, the half angle formula for the tangent of alpha over 2. So tangent alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. And so these half-angle formulas, now that we have solved for cosine alpha, we can just directly plug that value in and get all of our values. So let's go ahead and do that. So let's start with the sine of alpha over 2. So let's bring this down here, and let's start by analyzing whether or not we're going to take the positive or the negative of this square root. So if we look back to our All Students Take Calculus, angle alpha was between pi and 3 pi over 2, which was in quadrant 3. But the half angle alpha over 2 is in quadrant 2, right? It's between pi over 2 and 3 pi over 4. And in quadrant 2, the sign is always positive. So we're going to take the positive of this square root. And so now we can write this as the square root of, I'm going to leave some space because we're going to have a fraction in the numerator, right? 1 minus the cosine of alpha, which is negative 8 over 17. So minus 8 over 17. And it's going to be over 2. And let's do some quick mental math in our heads. 1 is the same as 17 over 17. 17 is now the common denominator. 17 minus negative 8 is 25. So now we're going to have 25 over 17. And this is still all divided by 2. And we can actually kick this 2 up like this to the denominator and make it 17 times 2, which would give us the square root of 25 over 34, which we can reduce further down to, because we can break up the square root into the square root of the numerator over the square root of the denominator. The square root of the numerator is the square root of 25, which is 5. So this is going to be equal to 5. And the square root of 34 does not simplify. So we're going to leave it like that. And then we can rationalize the denominator by multiplying by root 34 over root 34. And these square roots will cancel here. And what we're going to end up getting is 5 square root 34 over 34. And that is our final answer for sine alpha over 2. Now, let's do the cosine of alpha over 2. So the cosine of alpha over 2, let's bring that down here. We're going to start by doing the exact same thing. We're going to analyze whether we're going to take the positive or the negative here. So let's flip back to the other page. And we know alpha over 2 is in quadrant 2. And in quadrant 2, the cosine is always negative. So we're going to take the negative of this square root. And so now we can do the same thing as we did, very similar to the previous step for sine alpha over 2. We'll have negative, very important, don't forget that, square root of 1 plus cosine alpha is negative 8 over 17. And this is over 2. Okay, let's do some mental math. 1 is 17 over 17. 17 over 17 minus 8 over 17. That's 9 over 17. So this is going to be negative square root 9 over 17, which is also over 2. Kick up this 2. 17 times 2, that's 34. We're going to get negative square root of 9 over 34. And then we can break up the square root into the square root of the numerator and the square root of the denominator. Square root of 9, that's 3. So this is negative 3 over square root 34. And as we know from before, square root 34 does not simplify, so we're going to rationalize the denominator here. So multiply by the square root of 34 over the square root of 34 so that the square roots cancel in the denominator. Can't draw my square roots right now. Like this. So now that these are going to cancel. And what we're left with is negative 3 square root of 34 over 34. And that is our final answer for the cosine of alpha over 2. And finally, the last half angle we have to calculate is for the tangent. So let's look back and see whether we're going to take the positive or the negative of this square root. So the half angle is in quadrant 2. And in quadrant 2, tangent is always negative. So we're going to take the negative of this square root here. And we can say this is equal to negative. We're going to need a pretty big square root here. 1 minus the cosine of alpha is negative 8 over 17. And this is over 1 plus cosine of alpha, which is negative 8 over 17. And we can say this is equal to negative the numerator, 17 over 17, minus a negative 8 over 17. That's going to be 25 over 17. So let's put that there, 25 over 17. And then this is all over 1 plus negative 8 over 17. That's 17 over 17 minus 8 over 17. That would be 9 over 17. And to reduce this fraction here, you can just kind of forget about these 17s here. And this will be equal to negative square root of 25 over 9, which we can reduce down to negative 5 over 3. And that is our last and final answer for the half angles. And that's it. We have successfully found the exact value of all three of these half angles. To recap, we talked about the reciprocals of trigonometric functions, the signage of those trigonometric functions with respect to their angle and quadrant using the all students take calculus trick, and then we found the quadrant of the half angle, and then we found the cosine of alpha using the secant of alpha that was given to us in the problem, which we used in the half angle formulas to calculate the exact values, but we also had to pay attention to the signage and make sure that because our half angle was in quadrant 2, we chose the right sign for our exact value. And these are our final answers. So if you enjoyed this video, please leave a like. It took a lot of work, and it would mean a lot to me if you could share it with somebody you think could benefit from it. Check out another one of my videos if you want to learn more, and subscribe to my channel for more math and educational content. Have a great day, everyone, and I'll see you in the next video.